Hello, welcome. I'm going to, in this video, be doing quest 19. I noticed in the last video that the audio was kind of hissy. I think that's been a problem with all of my recordings so far. I apologize for that, for the dozen, maybe even 2 dozen people who've watched my previous recordings. Sorry about that. Um, Hopefully what I'm doing now with the audio will make that hissing sound go away. So before we open quest 19, let's get our skeleton code in place. And so I'm just going to copy this from quest 18. Folder. New file. Okay. 9, 9, 9. And we're going to set this up as problem 1, problem 2, problem 3. Come on, go. Yes, I most recently opened Visual Studio Code and it had, oh, we've updated, and yeah, okay. So the first time you do something with Go, I found after I do that, it has to do that for a bit to figure out where we are. Okay, so quest 19, we have parts 1, 2, and 3. This, we are all set up. Yes, good. I pushed my quest 18 stuff up. And now I just have to say dot create. I'm just going to return instead of panic. Yes, and I know those parentheses aren't necessary, but okay, that's a decent enough skeleton. Right, here we go. Quest 19. Encrypted duck. During the tournament, the order, as you navigate through the narrow corridors, you come to a large chamber well lit by sunlight streaming. In the center lies a stone tomb with a plaque on it. Sir, it's a nice method to communicate without the risk of messages being during the Great Ram War. At the tomb, there are many books placed on pedestals. In addition to the deed, you also find a book containing the message encryption. Turns out to be very simple yet clever. Message is hidden in a grid of characters. Series of rotations on every rotation point on the grid according to the message key. Start with each cell on the grid has neighboring cells, including diagonals. The number of neighboring cells depends on what the grid is in the corner, or on the edge, or elsewhere. Rotation point is a cell that has 8 neighboring cells. Okay. To untangle, you need to rotate the 8 cells surrounding each rotation point to the left or to the right according to the message key. Starting from the top leftmost rotation point, continuing through all rotation points to the right on the same row, then proceed to the following row, left to right. Note the border cells are not rotation points. There are 2 possible R. Rotate them that way. L. Rotate them that way. The message contains a sequence of R and L operations. key is shorter than the number of operations required, simply repeat the key again and again and again. Final message always starts after the and ends before the characters. Characters are always unique within the grid. You decide to code a sample message from the book. Okay. First line contains a message key. Key to read the message. Perform sequence. 3 page. Okay, so we rotate that left. Rotate that right. Rotate that left. Rotate that right. Confirm the coding is successful. Same line. Okay. Let's see what we're dealing with here. We're dealing with that, and so it'll end up being a number, almost certainly. Okay. Download that. Download. Anybody remember Homestar Runner? I bet that site is probably still going somehow. I'm not going to check it out right now. Okay, so what do we have? Okay, so we just repeat that. Okay, so func rotate grid byte and dir int and when we get back we get actually no, we're going to text grid in place. There is 1 for right / clockwise, -1 for left. Okay, and then for row dx1, row idx less than len grid -1, row idx plus or call idx 1. Okay. Clearly my fingers are, my right hand is just not hitting the top row properly. I should probably adjust. Call idx less than len of grid 0. Call idx plus. And then let's see. So I want yeah. -1, -1, -1, 0, 0, 1, 1, 1. So what these are, these are what I have to add to a piece in the center to get the pieces around the edge. And then what we're going to do is we're going to say for, yeah, we're going to say old stuff eight for IDX range row offsets old stuff equal old stuff IDX equals grid bracket row IDX. Yeah, I don't know what's going on with my right hand here. I seem to be fumbling all sorts of stuff that should be typed with my right hand, so I don't know what's going on there. That, and then once we have all that, we do it again, and we say that the equals old stuff IDX. Now, if we're going one to the left, so for left, I want to be looking at old stuff from the right. So I want to say, so given the conventions I've defined, I want to say old stuff minus dir plus 8%. The plus 8 is because Go uses the same conventions for percent modulus as C or Java does, or I guess JavaScript as well, and not the conventions that Perl, Python, and Ruby do. Those languages mean different things by the percent character when the left-hand argument is negative. So that is equal that. And now here I do. Okay, this, if you've watched any of my previous streams, is just exactly what we always do. We do buffio.new scan. Yeah, you know, I really should make this part of the skeleton at this point. So first we do scanner.scan. Key is scanner.text. Scanner.scan. And then grid make then for scanner.scan grid append slices dot clone. Yeah, we learned this the hard way the last time. Scanner.bytes reuses data that will be overwritten by a subsequent call to scan. Yes. Therefore, we really want to clone it at this point. So, oh, well, this is obviously wrong because this is doing all of the things, but it's taking in only one dir. So actually, what we need to take in here is string is a string, a key string. So 0, and then let's see. So dir byte x if dir byte l switch dir byte case l key dir equals -1 int case r dir equals 1 default log dot fatal bad key character dir byte. Problem 1 there, and then I will what we have to have the one row. So I'm just going to print out the whole grid and use my human eyes to copy out the middle thing because I don't see a reason not to. So then so here we do rotate grid key row and range grid. Turn row into a string because row is just a byte array at that point. And yeah. Interesting. Okay, so this should have been totally within bounds. Index out of range 18, length 18. So, oh, that, there, that's what I was missing. Okay, what did I do? Did I rotate it wrong? I thought I might get that backwards. So let's try that. Nope. That's also wrong. Okay, so we have this. Case L. Okay, so let's just do one let's just do one rotation. Okay, so we do this, and now let's look at what we started with. Okay, so oh, right, I put these two things are in the wrong order. What they should be is they should be in the order. They should be in that order, and I put them in the order. I put them in the wrong order. Yeah, I put them in that order, which is wrong. So let me do this. So those first three things are right, and then the second one should be 0, but after that, we should then have 1, 1, 1, and then comma 0. This, we should have the first three are that. The next one is a 1. So it's also a 1, and then we have 1, 0, negative 1. Okay, that should be more like it. Let's go run that. Okay, yeah. And here I was correct the first time I did that. Oh, right, because I'm still only doing one rotation. Okay, I am suspicious of that because I expected it to be all numeric. So I'm going to double check it with this input. File, save as. And I'm really sorry, guys, that it's taking me so long to just get part 1. I don't know what's up with me tonight. Oh. Okay, yeah, so clearly I'm not rotating quite correctly. So how does that, yeah, that shouldn't happen. There is something in my rotation that is incorrect. So let me see. Negative 1, negative 1, negative 1, 0, 1, 1, 0, call. Negative 1, 0, 1, 1, 2, 3. Aha. There we go. Oh, that's much better. Yeah, 22 minutes, not great. Of course, it's just misleading. Additionally, processing method key only once was deemed insufficient. Code. Standard messages assume that operations the whole message need to be repeated 100 times. Another riddle in the book. Okay, before you can see all the rotation points highlighted for. Okay, so we have 4 rotations. 1, 2, 3, 4. 1, 2, 3, 4, 5. 2, 3, 4. But it'll, yeah. Number during the battle with the HTML. What was the HTML? Did they say here? They had that. RAM was the real allocation mayhem war. Did they? The hulking tapestry, mighty Leviathan. Gotcha. Okay, well, let's pull our input over. Okay, so um, okay, so then this is just becomes for range 100. Do that. Cute. Yay. Test involves deciphering another. Had agreed to use, okay, over 1 billion rotations. Deciphering another message to count the number of nights on Little Ending Island. Not Little Endian, Little Ending Island. Preparing legions for. Okay, so one. That is an interesting number. This 104. Okay, so it's 15K, and we're doing this 1 billion times. So I got to find a faster way to do this. Unfortunately, I'm worried that overall there's not going to be a. I'm vaguely worried that overall there's not going to be a repetition. However, maybe there could be a repetition. So what I'm going to do is I'm going to, yeah, let's do this until we find a repetition. And if we find a repetition and we have something earlier, we can just jump to the very end. I hope. Okay, so let's hope. So we're not going to do that. We're going to do okay, so we're going to do that. And yeah. So then how do we to crypto MD5 crypto MD5. Tell me about this. New cryptographically broken should not be used for secure. Well, this is not secure. And yeah, I could use something other than MD5. I could use the SHA-256 if I really cared. But hash. Okay. So new hash computing via MD5 checksum. Okay, and so I can do this each new. I can write each bytes to it. Um, yeah. Okay, functions. Just new and we have sum. Do we have a way to digest, partial, unmartial, size, block size, sum? Nope. Okay, so um, apparently I can write to this. Record make map from bytes to a int, and it's saying that can't do it. We can't do that. Okay, so I need basically what I need is a sealed, actually, what is this? This sum. What return type is sum? Data bytes, but I could do this. I could do const size is 16. Does that? Yeah, that works. So I'm going to say md5 dot size byte to int, and then yeah, okay. So if after yeah, so I'm actually going to this. So we have to do yeah, I'm actually going to make this 1 and make this less than or equal to, because I want the number of rotations to be here. And I could put in a 0 as well, but I'm not gonna. Um, so rotate that, and then um, h equals md5 dot new, declare h equals md5 dot new, h for row, for under row range grid io dot write copy, an io.writer copies. Okay, now what is an io.writer? Go io.writer. What are the io.writer interface? Oh, okay, so we do have a write. Can we just say h.write? Yes, okay. I should have trusted that. h.write row. And I'm going to ignore the return value. And then s h dot sum appends the current slice to be appends the current slice. Okay, sum of nil, and then slices dot or IDX range. Oh, actually, there's like a 2 array or something. There's a standard way to do Golang copy array slice. Okay, I don't necessarily trust that that Google AI thing. I've found that the Google AI search very rarely hallucinates, but very rarely is not the same as never. So key make md5 dot size byte. Actually, var key md5 dot size byte. Okay, key is a byte array, and that doesn't really work. So I'm going to say that. And then if val okay record of key okay else. So if we found something, then that means that value is the last time we saw this. So then step rotnum minus val, and then we have rotnum plus equals that so this is going to seem a little weird, but I want to subtract some, and this is just giving me some room for error. I don't want to accidentally advance the rotation number too much. So this minus rotnum slash step this will put me down, and maybe I'll have to go through another extra rotation number steps, but I think that's okay. And then just so I don't try to yeah, that's okay, and that should work out fine. Else record of key equals rotnum. Okay, so let's yeah, that should that might work. Let's make sure I download the code. Oh, looks like I already got it and moved it into place. Well, once it does move it. Man, so much different than Unix, just in all of its little defaults. Okay. Okay, part 1, part 2. Then part 3 is taking a while. I'm wondering for part 3 if I'm not supposed to maybe figure out, what happens if you take this, take a position, a byte position, and you apply all these thousands of rotations to it. If maybe there's some way to figure out, given a position, given something that started here, where does it end up after a billion plus rotations? Um, maybe that's a more productive approach. So let's imagine that you had a piece. So I think this is going to be several different cases. And I think we're going to have to start with a piece on the edge. Yeah, because I don't think this is gonna work here. So if you have that is cute ASCII art that they wrote there. But so if you have a piece on the edge, oh, and we have also, to complicate things, we have the key that like tells us to rotate right, rotate left, rotate. Shuffles stuff all over. So if we rotate this to the right, yeah. So okay, so first what I'm going to do is I'm just going to double check that the key is a factor of the size of the whole thing. The length of the key is a factor of the size of the whole thing, and I have no idea. So I don't like doing it, but I think I'll have to exit that here. So let me just say here before we do this, oh man, look at the time. It's already been 50 minutes. I'm sorry, guys. This is just a slow night, I guess, for me. Key size, lang key. Grid dims, lang grid, rows of lang grid 0 calls. Okay, we're just going to interrupt that. Okay, key size is 129. 77 rows of 200 columns. Okay. "77 rows of 200 columns." So Python So we have then for the number of rotation points, we have 75 times 198, 14850, 129. Yeah, okay. So this is not at all even. This does not fit, the key doesn't fit evenly. We're going to have to keep going. Wait. One thing, so here's something that I was a little bit confused about. And I thought about it in part 2. I didn't mention anything at the time, but um, each time you start from the top, okay. So we reset the key each time, so it doesn't matter whether the grid, whether the rotations are, it doesn't matter whether the rotations are a factor of the size of the grid. Okay. Okay, so I am doing that correctly. Each time you start from the top left rotation point and from the beginning of the key sequence. Okay, so though clearly it doesn't in the first yeah, if Rotnum yeah. So I believe my code is in fact going through and doing these rotations, but keeping up with things, and especially uh, keeping up with the horrible um, number of map entries. Um, so suppose that we do have these. Suppose that we do have a repetition. I wonder how badly doing this MD5 sum is slowing us down. So we've seen it going here, and I'll time it a little bit. I'll wait till the next one pops up. I'll time it by the little counter showing me how long I've spent on this. So it popped up at 36 seconds after in my counter here of, okay, 47. So it's maybe 10, 11 seconds per 10,000. Okay, now, what if we don't do any of that? Oh, yeah. I have mentioned before that I don't think I'm overall a fan of the whole you declared this thing but never used it, therefore we're going to uh, say that it's an error and we can't finish can't, okay, wait, I missed it. Let me watch for the 20,000. 20,000 was roughly 45. 30,000 roughly 50. Okay, so it does not appear offhand that the MD5 sum is slowing us down at all. The it might be slowing us down by 10%, which honestly suggests to me that there must be a much faster way to just do a single rotation. However, even if I had that, I'm not sure that would get me to where we need to be, which is a faster way to do a billion rotations. I still think that the way is going to somehow involve figuring out where each individual character goes. Have to admit, I'm not entirely sure about that. But so each individual character is going to be affected the same way. Oh. Oh. So each position is going to be affected the same way each time through the rotation. So, in fact, you could daisy chain all these things together. And, So I don't know it, but yeah, because there might be distinct cycles, so you don't actually know that. I'm sorry, I'm babbling and going off. So okay, I think though I know how to solve it, at least in part. What we need to do now is we need to figure out of the 15,400 spots in the final character, which spot goes to which, and then how many distinct cycles do we have? What are the cycle lengths? Come up with the least common multiple of those, stretch that out, and then rotate enough times. Okay. Yeah. So let's stop this. Okay. This is not going to work. Okay, so what we're going to do is we're going to do okay, and we're going to so in theory, there's probably some way we could go through and yeah, okay, so I'm going to do this in a way that's going to be a little slow, but a little slow means that it'll take maybe 15-20 seconds instead of milliseconds. So let's just do that. Let's be done because I've already spent over an hour on this problem, and as I know in the past, when I spend too long, my screen recording tool just up and dies and doesn't save the screen recording. So make byte is going to be len of grid. for row range grid blank grid idx make byte actually len row. Okay, so we have a blank grid that is all 0 bytes. That's what go make does. And then what we're going to do is we're going to have a type point struct x comma y int, as again the x is going to be the row and the y is going to be the column, which means the vertical and horizontal is mixed up for people who get upset about that, but it just because that's the order. And then what I'm going to do is I'm going to for row idx range row actually I can just do range grid range when grid 0. We're going to do start point row call. Nope. That. And then we're going to do blank grid bracket row idx call idx equals 1. Rotate blank grid key. And now we're going to find the endpoint. Var point end var end point for row idx row range blank grid if slices dot okay, this is row idx end row idx slices dot index row 1. Okay, index I assume in Go returns -1. Yeah, if CIDX greater than or equal to 0, endpoint equals point end row idx CIDX break. Okay, and then transform make map point point. Okay, and then we just say transform of start point equals end point. Okay, now cycles make point. Okay, so what we're going to do is we're going to grab something, we're going to find everything it goes to. Yeah, we're going to grab something, find everything it goes to, delete those from the transform as we go, put it in cycles. When we're done, we'll find cycles, all the cycle lengths, and yeah. So this is for len transform greater than 0, for spot var start point range transform now for yeah, so we start point to next start point and then break. So for true, 0 for true. C point if C point colon equals trans bracket C point okay else else we're done. So delete transform those are the arguments I want. Delete map that. Yeah. If C point okay. Okay, so if we have something, then we say okay, then we add it to, then we add the new thing to C point. Okay, so this is n, then we say C point equals C point n, cycle.append C point, else break. Okay. Okay, and that'll clear it, and that'll clear it out. And then we say down here, cycles, append cycles, cycle. Okay. Then I need an LCM routine. Shoot, I have an LCM routine in one of these earlier ones. Which one was it? Was it 14? No, 13. Or wait, maybe it was 16. I had an LCM routine. There we go. I knew I had it. Okay, so problem 3 here, there. So cycles is that. So one for cycles, and here I want to say range cycles, cycle LCM equals LCM, cycle LCM when cycle. Okay, and then we say start rot num equals this big number. Actually, let me copy that big number. Can I do a local const? Const. Okay. Big rot count. Part 3 rot count. Okay, so what I want to do is I want to do this. So having done 0 rotations is the same as having done that many rotations. Okay, so cycle LCM times big rot count slash cycle LCM. Okay. Okay, so it's first got to figure out all the transforms, then it's got to do this. Okay. Well, that's a big pile of nothing. Damn. And I was feeling so clever. Okay, so let's see what happened. So this should also work for earlier problems. I think. Oh, except that with an earlier well, wait, do we have any sample input? No, we don't. Damn. So okay, so let me okay, so this didn't work. Debug. I just want to see with all these cycles if it's like one big cycle or what's going on. Okay, so this is obviously wrong. Okay, that's good. Okay, because that means that we clearly did something wrong here. And oh, this is wrong. Um, uh, row bracket CIDX equals 0. Yeah. Okay, we still end up with all of these debug cycle length of 1. Okay. I just want to see if the first cycle is not 1. Yeah, okay. So all these things have a okay, so we oh, the duh. This is stupid. There. It could never be okay. So what is the problem here? Oh, because I return. Okay. Stack Overflow? That's really weird. Okay, 203, 205, 203, 205, 203, 205. Okay, so okay, so clearly something went wrong here. Um, so okay, actually, let's do this. Let's do a comma b equals b comma a. A comma b equals b comma a. So a is the smaller one. Then we do that. If a less than 0 or b less than 0, panic. Log.fatal. Okay. I mean, not that you can't have negative arguments to GCD, but you're not supposed to. I mean, in this program, have negative arguments to GCD. So if that happens, something very wrong has gone on, and I need to know what is going on. Okay. Oh. So what's happening is that the least common multiple of all these cycles, haha, the least common multiple of all these cycles doesn't actually help us, because the least common multiple of all these cycles exceeds the size of an integer. Okay, and so, okay, so GCD, LCM, it's been nice knowing you. Goodbye. Okay, so we can't actually compute this. Can't actually do that. But what we can do is we can use each cycle to transform the points. We use the points to figure out what to turn each thing into. Okay, so now for cycle range cycles. Okay, so we're going to do all these cycles manually. I have stash is make byte len cycle. Okay, so what we are going to do is we are going to, yes, everything in the cycle is like that. And what we're going to do is if we were to rotate ahead 1, we would be looking, when we were looking to replace the thing in that cycle, we would look to the thing in stuff plus 1. So we'll look at the thing stuff plus big root. Yes, okay. Sorry, that was probably incoherent hearing it, but I think you kind of know where I'm going. Stash is that. So for IDX point range cycle stash bracket IDX equals grid bracket point dot x point dot y. Then we have for IDX range cycle okay, actually, right, IDX point range cycle source IDX is going to be equal to big rote count percent len cycle, and this will be actually what we'll want is we'll want IDX plus big root count cycle, and yeah, then we'll just say stash source IDX. Okay, and let's try that. Nope. Darn, I really thought that was going to be it. Okay, so we have all these cycles. Do you suppose it's supposed to be going the other way around. Nope. Okay, so well, now this should work. So let me assume I was correct here before. And then so scanner one was just problem one was just doing that. So let's say, what if big root count was just 1? Q19P. Oh, I didn't want SAMP, but okay. So clearly there is something wrong. There is something very wrong with my method of doing this. Okay. So let me double check here. Print line G transform length len transform, and let me check here if I can do len cycle. Okay. 54 is the number of things that should okay, so 54 is in fact 3 times 18, and now 462. I can't add up all those numbers all at once. Sheets.new, edit, paste, edit, paste special. Shoot, this won't work. Split text to columns. Okay, what's the sum? The sum there is 74. Interesting. So I'm finding more cycles than actually exist. Well, that's interesting. Okay, so there are supposed to be 54 things in transform. I'm finding this. So, okay, let's go back here. Yeah, this is the stupidest way of using a using a way overpowered tool to add a bunch of numbers, but yeah. Okay, and I gotta hurry up because I am at 1:35, and if I do not finish this before too long, it will crash, the recording thing. And then I'll have no Quest 19 because I'll have already seen it, and I can't, see it for the first time again. I'm not gonna fake that. So anyway, here, let's debug cycling. see what that looks like. Okay, remaining 6, remaining in transform 49. Okay, so I'm not clearing out the last one. Or am I clearing out one too many? I think I'm clearing out one too many. Okay, so I should find my way back to, so if we have next C point is that, then we append C point, we delete C point, else if C point 0 at okay, that's good. We are making our way around. Okay, now, okay, so this is just one. Okay. What if we say, just because maybe I got it backwards. Yeah, I figured. Okay, maybe I got it backwards. I did get it backwards. Okay, so that works, but I have to go backwards. So what I want is I want minus this okay. And now oh shoot, we'll have a lot of debug lines. Oh well. There it is. Where's the message? Yay. Okay. Well, there you go. Yeah, I think I'm gonna, before I post this code, I think I'm gonna clean it up, obviously removing all of the debug lines here, or at least commenting them out. And then I think I'm going to, you know what, actually, I have time to do this on stream. Or not stream. It's not streaming. I don't stream. I am experimenting with screencasts. That's all. That's totally different thing than streaming. So, okay. I'm doing that. And then what I'm going to do is I'm going to build something that finds the text between the two angle brackets, returns just that, and then add a flag, because I'm always doing this flag.parse. So I honestly have not used Go's flag method that often. So let me, oh, it's doing it over in a different window. So okay, so let's see, how do we use this? How do we use this program? We say, okay, we just say something equals flag dot, yeah. So wait, what, var flagful flag dot whatever. Okay, so var show full flag dot okay, what is it? Flag dot string. Okay, var oh, no colon equals. That's it. Flag dot bool string boolean string verbose false okay. And now what I'm going to do is I'm going to do a thing that does a find the for row comma grid range grid um, slices dot index row if C1 continue, then C2 IDX slices dot index row if C2 IDX less than C1 IDX string of row C1 IDX plus 1 colon C2 IDX. Copy. Okay, return to message grid if show full show full dot what? Okay. Okay, flags.parse. If you using the flags themselves, they're all pointers. So, okay, so if show full, there. That, okay. If star show full return find message grid if star show full find message grid yeah. You know what? So that's fine. And now I can do this. I can also say quest 19 verbose. Yep, and see, now it shows the whole thing. You know, to show you the ASCII art in case you wanted to see it. But I don't like, this is ugly. It worked, but it's kind of ugly. And I think that what I would prefer to do slices dot reverse cycle, and then here just do idx plus big rot count. Yeah, so let's run it without the verbose. Come on. Yeah, there we go. Okay, so that's it. I'm going to stop this stream, and I think I have gotten the hang of YouTube end cards, or at least gotten some sort of feel for them. So hopefully, if I've done that correctly, they'll be down in this area down here in the bottom right, a link to a playlist of all of my Everybody Codes walkthroughs. Is that what these aren't walkthroughs? These are solve. I don't know. Whatever. Because I'm seeing the problems for the first time. I have not looked at them before I make these videos. Um, anyway, right. There should be a playlist down here. We'll see if that works. And thank you for watching. Assuming you've watched this far, I hope this is useful and an enjoyable way to pass 2 hours. Really? Okay. Yeah. That's just too much.